Alrighty, homework starts on page 540, and we're going to start with, well, actually, real quick on number 1, remember our knuckle trick. So we got our knuckles right. The ones that you have on your knuckles is the ones that have 31 days. So we go January, down February, March, April, May, June, July, August, September, October, November, December, and then you got this pinky left over. So you gotta look at it like that. You'll have your two knuckles next to each other, so that means both of those months have 31 days. So July and August have 31 days. So that's for number 1 to help you out. And not a leap year means that February, which we talked about, I believe, when we did it, but if it's not a leap year, then February has 28 days. If it is a leap year, it has 29, but if it is not, there's 28 days in February. Alright, but I'm going to do number 5 with you, and number 5 says Melinda paid the clerk $20 for a book that was priced at $8.95. The tax was 54 cents. How much money should she get back? So this is what we did yesterday. And remember, we have to do 2 steps. So first we have to add the tax to our total and then subtract that total from how much we paid. So let's go ahead and add 54 cents to $8.95. So I'm just going to go ahead and write my 54 here. That way I can save space. So 4 plus 5 is 9. 5 plus 9 is 14. Carry that 1. Make sure I bring down that decimal. And 8 plus 1 is 9. So then the total is $9.49. So plus tax, it's $9.49. And now Melinda paid with $20. So we got to figure out how much change she'll get back. Again, this is all very, very useful for the future. So $20. Like, I worked at Dippin' Dots at the fair. I had to do math. Even though machines do it for you, like a cash register or your phone does it for you, you still have to know how to put in the information. Alrighty, so we're going to put our 9 there, decimal there, 49 cents, and we subtract. So we can't subtract 9 from 0, so we turn that into a 10, and just like I said yesterday, if it's zeros, if it's a number and then some zeros, nothing in between, you can just take this whole number and treat it like it's 200. And then if that's 200 and you take 1 away, it becomes 199. So this turns into a 9, that turns into a 9, and that turns into a 1. Again, it only works if this is 2 zeros, or I guess 3 zeros, however many zeros, but you can't have like 2010. It wouldn't work like that. You have to have it be a nice 100 or a number that ends in 0. So 9 subtracted from 10, you get 1. 4 subtracted from 9, you get 5. Bring down that decimal. 9 subtracted from 9, you get 0. And 0 subtracted from 1, you get 1. So she gets back $10.51. Yeah, she just gets back $10.51. Alright, 6a says, which 2 prime numbers are factors of 15? Now remember, prime numbers means that they're only multiplied by 1 in itself. So prime number means multiplied by 1 and itself. So times 1 in itself. So it also says factors. Factors are just the numbers for multiplying. So what 2 prime numbers are factors of 15? Now we can figure out what numbers multiply to 15. So 1 times 15. That's factors of 15. What else? We can do 3 times 5 is 15. And I believe those are the only pairs that we can, or only numbers, factors that we can have to multiply to 15. Now, 15 is not prime because, just like we figured out, it has another set of multiples. So it can't be that one. So it must be this one, because 3 is a prime number because it's only, you can only multiply, its only factors are 1 in itself. Sorry. So 3's only factors are 1 in itself. Same with 5. You can't do 2 times 2 because that's 4. 2 times 3, 6. So these are both prime numbers. So your answer then is 3 and 5. So 3 and 5 is your answer. And B says, is 15 a prime number? Why or why not? And I just said, no, it's not, because it is multiplied. It's got multiples of 3 and 5. So you can just write no. You don't have to write the why, just write no, because I just said the why, because it is multiplied by more than 1 in itself. So prime numbers, I know it's been a while since we have had to deal with those, but there we are. Alright, the next one I'm doing is number 9. Whew, that looks cool. Alrighty, number 9, A says the Mendez family hiked, 9A, Mendez family hiked 15 miles in one day. At that rate, how many miles would they hike in 5 days? So 5 days? I don't know. Let's see, 15 to 1. Make a table to solve the problem. So let's make our table. We'll do days here and miles here. So 1 day equals 15 miles. We have 2 days, 3 days, 4 days, and 5 days. So, like we've done before, and when it asks for rate, rate means multiply. So 1 times 15 is 15. 2 times 15, which you might not be able to do it in your head, but you can do 2 times 5 is 10. Carry that 1. 2 times 1 is 2, plus 1 is 30. And then, or you can just keep adding 15. So 15 plus 15, 30. 30 plus 15, we have, what is it? 3, 4, 45, right? Oh yeah, I can think of it as minutes too. 15 minutes, 30 minutes, 45 minutes. Then you have 60, because 45 plus 15, 60. 60 plus 15 is, we got a 5, 6, 75. That's right? Yeah. Let me just check and make sure. Yep, that is correct. So you can just multiply 2 times 15, 3 times 15, 4 times 15, 5 times 15, or you can just keep adding 15 to the next one. It is up to you, but rate means we multiply. Because if I didn't do all this, instead of drawing out this whole table, I can just say, how many in 5 days? I can just say 5 times 15 will give me my answer without having to do all of this. So this is to help you visualize and see it and see how the rate works. But if you didn't have to do this, then you can just multiply 5 times 15 and get your answer. Okay, so at that rate, how many miles would they hike in 5 days? Well, here we are, 75 miles. Oops. Miles. Remember, MI is the abbreviation for miles. Now part B asks, write an equation to represent the data in the table. So kind of what I just said is that you can multiply the number times 15. So let me just make sure. Just write the number of days, number of days times 15 is equal to miles. So that's what I was saying here, and that's it just written out. So in a equation that we have seen normally, it could be like 15D equals miles, because we've seen that before. So we could do 15D equals, let's say, 60 miles. And then we'd be able to figure out how many days. So days times 15 equals miles is how you do that. Alrighty, so also real quick with number 10, so I said with number 9, rate equals multiplication, and average you are going to divide. So on number 10, it says Mila picked 3,640 peaches in 7 days. She picked an average of how many peaches each day. It also has each. So average, and each, when they're together, they mean divide, because you can have an average and multiply, but together, they want to know the average. You think, okay, in 7 days, so we have 7 days, ready, 1, 2, 3, 4, 5, 6, and 7. So we have 7 days. I'm not going to do 10 with you, sorry, but this is me just trying to help you visualize number 7 or 10 if that's what you're having trouble with. So picture it as we have our 7 days. In total, in all of these days, so all together, she picked 3,640 peaches. And we want to know how much on each day. So that's how we divide. We can't just find the word each and think, oh yes, I'm multiplying. We have to kind of picture it in our head or draw it out and think, do I need a bigger number than this, or is this my biggest number? Now this is telling you that that's how much she picked, so she couldn't have picked any more, so that is our biggest number, meaning we have to divide. So if that's something you're struggling with, hopefully that helps make it make more sense, but draw a picture. Take word problems slowly and have it make sense in your head instead of just reading the words and getting flustered by word problems. Take your time, read through it, draw pictures, whatever you need to do to make it make sense. Right, number 11A says Zachary did 1,000 push-ups. Last week, he did 129 of those push-ups on Wednesday. What fraction of the 1,000 push-ups did Zachary do last Wednesday? So they tell us that we're going to do a fraction. And what do you know? Today we did fractions with the thousandths place value. So we can go ahead and put our 1,000 on the bottom because he did a total of 1,000. But we want to know how much he did on Wednesday. So we just put that number on top. 129 thousandths is the fraction of push-ups he did on Wednesday. And that is your answer. And remember, you can just write 129, that dash, and then thousandth when you type in your answer. B says write the answer to part A as a decimal number and then use words to name the number. So as a decimal, which if you have that little cheat sheet that I left for you on your paper from your examples, you'll know then that we always put that 0 first, decimal, or if there's a number there. And then these are just going to fill in those place values. We have our tenths place value, hundredths place value, thousandths place value, and that is the decimal. Now as words, we can go ahead and we say 129 thousandths. So I'm just going to write down those words. 120 9 thousandths. And there you go. Next one I'm doing is 12. And this says, suppose that an object on Earth has a known mass of 80 kilograms. So remember, mass is different than weight. because mass is always the same, your weight depends on gravity. Will the mass of that object be less than? So is that going to be less than, more than, or the same as, which is equal to, or the same as other planets in our solar system? So is that going to be the same everywhere? And explain your answer. So if I said mass is always what you are, but your weight changes on gravity, that would mean that no matter where you are in Earth, in space, on a different planet, in water, your mass is always the same. So the mass of the object will be the same. And how did I word it? I'm trying to think of how it is on your question. I just said your mass will be the same. Something like that. If it says it's wrong, I know it's right. I know if you put this so that it's right. I just can't remember at the moment what I put on that form. Same with this one. It's still right because I'm doing it with you here, but if it says on your homework that it's wrong, that's just my bad. I don't remember what exactly I put in. Alrighty, so the next one we are going to do is 15, and 15 is 3 times 6 times 3 squared. I just picked this one because I haven't done these kinds with you in a while, and just kind of doing order of operation. I keep doing division, actually, not so much multiplying. So we're going to do this. Now first, I need to do the exponent, because I know I've kind of mentioned it before with PEMDAS, which I'll talk about, I'm sure, next year. But this is how you do your order of operation. So first you do parentheses, then you do exponent, then multiplication, then division, then adding, then subtracting. And that is how you'll always do your problem. So you could have something like 25 times 5 plus 6 divided by 3, whatever, keep going. You still have to do the order of operation. So you do that first, and then you'd add them. So order of operation tells you what order to do your math in. If you don't do it in the right order, you won't get the right answer. So we have to do our exponent first. And an exponent or squared number just means we're going to multiply it by itself. So 3 times 3 is 9. So we have 3 times 6 times 9. And whatever is easiest for you, I think, well, I'm terrible with 6s, so I'm just going to, but I'm good with my 3s, and I have my lovely finger tricks for 9. So I'm just going to do 3 times 6, which is 3, 6, 9, 12, 15, 18. I don't know why I chose that. Oh well, I'll do 18 times 9. You can do 3 times 6 times 9, and then do that times 9. You can do 6 times 9 times 3. You could break it up however you want. So you could do it that way, or you could do 9 times 3 and then multiply that by 6. However it is easiest for you. But I just did it this way. So 18 times 9. 8 times 9 is 72, right? 72. So put that 2 down, carry that 7. 9 times 1 is 9, plus 7 is 16. So 162 is our answer. Okie dokie. On to the next page. For number 27. 27 says to write 0.312 as a fraction. 27, 321 as a fraction. So it is we have tenths, hundredths, thousandths, so it's in the thousandths place value. So we have to write 1,000 at the bottom. And then the top number, or that number just goes on top. So that is our answer. That's how we write that as a fraction. So hopefully when we get this going, we can just quickly do it and put it into a fraction. Alrighty. 29. I am not going to do with you, but remember that, actually I'm just going to write this little thing on the board, or on the whiteboard, so when you do 29 you can just pause it on this, and instead of looking back at lesson 73, so I'll go back to lesson 73 hopefully quickly enough. 21, 73. Awesome. So we have slide is translation, and these are the words that you're writing down. So a slide, something like whoop, whoop, if you kind of slide it over. Then we have turn, which is rotation. And that's if, well, it's kind of hard to see, but if I had this Expo marker, I could turn it that way. Oh, it doesn't work that way. It needs to be flat. This is something I have. To turn it, I would just kind of turn it around like that. That is turning. Turning. And then we have flip. It's kind of like you flip a little pancake. That's called reflection. And a flip is just floop, like a little pancake. So if I'm gonna flip it, boop, like a little pancake. So these are the words that go on your homework. We can't just say slide, turn, flip. Don't ask me why. I'm not a math person. I just follow the rules of math. So if you slide something over, it's translation. If you turn something, it's a rotation. If you flip it over like a pancake, it's reflection. So keep those in mind for that number, what is it, 28? 29. Ask me any questions you might have, and I am happy to help you on whatever you're not understanding.